Hello there, welcome to the Learning of Engineering tutorials. In this video lecture, we are trying to learn a member subjected to simple shear stresses. In the last video lectures we have seen the normal stresses are acted on the member. That's going to be A, B, C, D is going to be the two-dimensional. It has its own thickness, is going to be unit we have considered. Now we are made to subjected to these faces. The BC is going to be subjecting and AD also subjecting the same magnitude, and that's AB and the DC also subjecting. Now we are acting here is the tau xy I am going to be considering is the shear stress acting on your face BC. So now what I am going to do, I need to find out here the loads are going to be, that is going to be, the loads are is the shear loads I have to calculate. That's going to be A, B and the D. So now I am going to be writing here, this is going to be your Q1 and here is going to be your Q1. Suppose this BC, whatever the stresses are acting, I can say that's going to be Q1. So this is going to be the AB is going to be your Q2 and here is also the Q2. The Q1 and the Q2 are the shear forces acting on that member. So now in this case what happened? We have the face oblique planes that we considered with the inclination of the theta. So now when I am going to be shifting from the BC and to the FC, so then what will happen? That same force is going to be acting on this one. It will become resolved into the two components. What are the components we do have? That's going to be, one is going to be the tangential component, one is going to be the normal component. That I am going to be taking here. This is going to be the Q1. So that's the Q1 cos theta I am going to be considering, and here this force is going to be coming. This is going to be the Q1 the sin theta I can consider it. Right, one is going to be the Q1 cos theta. So the second one is going to be okay, here this Q1 is going to be, suppose I am going to be taking this is the your FC face and here is going to be the Q1 is there. So then when the normal force is going to be coming this side as well as to this side, so then this is going to be the theta. So then in this case this one will become the Q1 sin theta and this is going to be the Q1 cos theta, we will get it. Sorry for here, this is going to be your sin theta and this is going to be your cos theta. And similarly the face AB also going to be subjected to the Q. That I am going to be resolving, the one force is going to be normal, another force is going to be parallel to this one in this direction. Right, and here also it is going to be making the theta. So in this case what will happen? So from this point this is going to be your Q2 and this is going to be the Q2 theta. This is going to be Q2 cos theta, right, and this Q2 sin theta we will get it. Right, one is going to be tangential, one is going to be normal. So in this case I am going to be taking the normal components. That's going to be the Pn is equal to the Q1. This is going to be the Q1 sin theta plus here that's going to be Q2 normal component is going to be the cos theta, right? And similarly the PT I am going to be taking, that is the tangential component. One is acting in the downward, another is the upward. The Q1 cos theta minus Q2 sin theta I am getting. So when I am going to be substituting what is the PT and what is the Pn. As we know, when we are going to be calculating the normal shear stresses, that's going to be sigma n is equal to Pn by A I am going to be taking, and similarly the PT suppose that's going to be the shear stress tau is equal to PT by area I am going to be considering. Right, so that I am going to be calculating what is the Q1, what is the Q2, that we need to define in terms of the tau xy. Right, so now I am going to be taking the Q1 is equal to, that is the shear force is equal to shear stress into area, that's going to be tau xy, that's the BC into unit thickness I am going to be considering. So finally Q1 is equal to tau xy BC, I will get it. This is the Q1. Then what is the Q2? How could you write it here? That's going to be, this is the unit area we have to consider, FB into the thickness we have to take it. So that I am going to be taking the tau xy. So then FB into unit thickness. So then finally the Q2 is equal to tau xy FB I am going to be taking. So once Q1 and Q2, then I am going to be substituting in this equation, so that I am going to be getting over here. Alright. So when I am substituting in this equation, that's going to be Pn into the Q1 will become tau xy bc sin theta, Q2 is equal to tau xy fb cos theta. Alright, this is, we got it. Right, and similarly the PT is equal to, how to write? The PT is equal to, the Q1 will become tau xy bc sin theta plus, sorry, here is going to be the minus, Q2 is equal to tau xy fb, this is going to be the cos theta, right? This is the cos theta and this is going to be your sin theta. So now I got the Pn and Pt, so then sigma n is equal to Pn by area, and the sigma, sorry, that is the tau is equal to Pt by area, I can take it. So that's going to be on the oblique plane, we need to be calculate. So here that is the sigma n is equal to Pn by area. What is the Pn here? That's going to be tau xy bc sin theta plus tau xy fb cos theta. Now by area we are going to be taking, which area we need to take it? We need to take this area, that's going to be fc into 1 I am going to be considering. Right, so that is the value, and further simplification of this one equation, BC by FC, the BC is going to be adjacent component and FC is going to be your diagonal. So that means in this case, if I am going to take the cos theta is equal to BC by FC, so sigma n is equal to tau xy cos theta sin theta plus tau xy, so this FB is the opposite side, by adjacent side, that's going to be sin theta cos theta, I will get it. So once I am getting the sin theta cos theta, I will take the common from here, that's going to be sigma n is equal to, so I am going to be writing here the tau xy, so this terminology is equal to 2 into tau xy, here is going to be your cos theta as sin theta. As we know, that is going to be 2 cos theta sin theta. Then how could you write here? The cos theta sin theta that I am going to be writing here, the sigma n is equal to tau xy into sin 2 theta, we got it. So this is going to be the normal stresses which are acting on your face FC, which is inclined to the face of the BC. Now we can calculate for the PT also. So now we are writing, that's going to be tau is equal to PT by area I am going to be taking. So what is the PT here? That's going to be tau here, tau xy BC cos theta minus tau xy FB sin theta divided by area of this one is going to be FC into unit thickness I am going to be considering. Right? So further simplification of this equation, we are going to be getting tau xy, that's BC by FC. BC by FC is going to be your cos, and here cos will become cos square theta minus tau xy. This will become FB by FC, that's going to be as sin square theta. Alright? So, and further simplification of this equation we are going to be getting. So how we are going to be getting? Alright? So this one I am going to taking tau xy, I am taking the common, that is equal to cos square theta minus sin square theta. So simplification of this one, that tau is equal to cos square theta minus sin square theta, that will become cos 2 theta. So can you see here, this is going to be the normal stress is acting on your face FC, and the shear stress is going to be acting on this face, this one. It means when your body is going to be subjected to the two shear stresses, even this plane will carry, can you see, this BC is carry only the shear stress, but when it comes to inclined position, inclined plane, that will carry normal as well as the shear stresses. So here we are going to be getting cos square theta minus sin square, that we are going to be getting the negative. The negative indication is that is acting in the downward direction. That means the shear force is going to be acting in this direction. Your normal stress is going to be acting. This is the sigma and this is the tau. So that plane is going to be suffering that kind of stresses. So this way we have calculated. So still, if you feel any difficulty or confusion in the derivation of this mathematical model, please put in the comment section so that I can reach you out. Thank you.